Hi friends, in this session we are going to see the derivation for logarithmic decrement. To derive this equation actually will require the equation of damped vibration. I'll write this equation and from this equation we'll take the help to derive the equation for logarithmic decrement. The displacement in damped vibration, it is given by zeta naught divided by root 1 minus zeta square into e raised to minus zeta omega n t sine in bracket root 1 minus zeta square omega n t plus tan inverse root 1 minus zeta square divided by zeta. So this is the formula for the damped vibration, which gives the displacement. Now with the help of this formula we are going to derive the logarithmic decrement. So to derive this logarithmic decrement, if you see this formula, then this formula is in the form of x is equal to x sine omega t. Here you can see this x is nothing but amplitude. So from the above equation, here you can see the first term x naught divided by this root into e raised to minus zeta omega n t is nothing but the amplitude of vibration for damped vibration. So here I'll write amplitude for the vibration, that is capital X is equal to x naught divided by root 1 minus zeta square into e raised to minus zeta omega n t. So this is the amplitude of vibration from above equation. And the next term is sine. This one is omega plus phi, and phi is the phase difference. So with the help of this formula we are going to derive the equation of vibration. Now from this formula you will get sine, this term is nothing but omega. So the omega means damped vibration, frequency of damped vibration is nothing but root 1 minus zeta square omega n. And by using this one, here we can see I have shown one graph of displacement against time for the damped vibration. So you can observe the amplitude at point A, it is more, and amplitude at point B is less. Means there is damping of this vibration. Means with each cycle the amplitude of vibration is decreasing. And if I consider the time period between A to B, then this time period is Tp is equal to 2 pi by omega. But this is the damped vibration, and for damped vibration the omega is root 1 minus zeta square omega n. From this formula here you can see it is the omega value, it is the omega d. Okay, so this is the time period. Now consider this vibration is started from this point, and till this point A, the time required, consider this time as Ta, or you can represent capital Ta. The time required till this point B, consider this time as Tb. Means after time Tb, the amplitude is this one. So I'll mark the amplitude also till this point. This amplitude is XA, and at point B the amplitude is XB. So from this figure what we are going to get, this is the graph of displacement with respect to time for damped vibration, where we have marked the 2 points. the time between the 2 points, means to complete time required to complete one cycle is the time period, and that is 2 pi by omega d, and the value of omega d is root 1 minus zeta square omega n. Now I have taken the time from initial, from 0 till the point A. So time required to complete A is Ta, and time required to complete the second cycle is Tb. Now from this figure, what we can write, Tb minus Ta is equal to Tb minus Ta. See, Tb minus Ta, in between these 2 points there will be Tp. Okay, so Tb minus Ta is nothing but Tp, and Tp is equal to 2 pi divided by root 1 minus zeta square into omega n. Okay, so this is the equation number 1. Okay, so we got the time period, that is Tb minus Ta. Now the next thing that we require for this derivation is determine the amplitude of vibration. Now amplitude of vibration, as we see in the figure, we have two amplitudes for two successive cycles. The first one is XA and second one is XB. So we'll determine the amplitude A and amplitude B. So what will be the amplitude A? See here, we have the formula of amplitude, okay, from the damped vibration formula, and we can directly write the amplitude for this one, x naught. X naught means this is the initial displacement which is given, divided by root 1 minus zeta square into e raised to minus zeta omega n t. But we are calculating for A, so the time required to complete this cycle is Ta. So here I'll write Ta. Okay, so instead of T, I'll write Ta. So this is the amplitude at A. Now if I want to calculate the amplitude at B, now how to calculate amplitude at B? Similarly, we can write amplitude at B equal to x naught divided by root 1 minus zeta square, the same formula, into e raised to minus zeta omega n t. But here we will have to time for the second amplitude, that is the amplitude at B, the time required is Tb. So here I'll mention Tb. Okay, so we have amplitude at A, amplitude at B. Now I'll name these equations. Suppose this equation is A, this equation is B. Now divide equation A by B. So here I'm going to make A by B. So XA by XB is equal to, I'll write the formula, x naught divided by root 1 minus zeta square into e raised to minus zeta omega n t A divided by XB is x naught divided by root 1 minus zeta square into e raised to minus zeta omega n Tb. Okay, so what we can cancel? From numerator we can cancel x naught, this root, x naught, this root, these two values are same, so I am going to cancel, and this equation will become XA by XB, that is the amplitude at A divided by amplitude at B, is equal to, what we can write here, e raised to minus zeta omega n Ta divided by e raised to minus zeta omega n Tb. Now we'll transfer this denominator to numerator. For that, see, whenever we transfer, suppose 1 divided by 10 raised to minus 2, when we transfer this 10 raised to minus 2 on the upper side, then this will become positive, so 10 raised to 2. Okay, so 1 divided by 10 raised to minus 2 is nothing but 10 raised to 2. Okay, so transfer this one on the upper side, so that this will become e raised to minus zeta omega n t a into e raised to plus zeta omega n t b. Why this become plus? Because we have transferred from denominator to numerator, so it will become plus. Now here you can see e raised to something into e raised to something. Suppose we have 10 raised to 2 into 10 raised to 3, then what we can write? 10 raised to 2 plus 3. Similarly here I'll write e raised to minus zeta omega n t a plus zeta omega n t b. Okay, so I have used this same 10 raised to 2 into 10 raised to 3, that is 10 raised to 2 plus 3. So here it becomes e raised to minus zeta omega n t a plus zeta omega n t b. Now what is the common in these two? That is the zeta omega n is common. So in bracket it will remain tb minus ta. tb minus ta. So this is the value of xa by xb. Now just go back and see the equation number 1. In equation number 1 we have the tb minus ta, that is the time period for b minus time period for a, and it is 2 pi divided by root 1 minus zeta square omega n. So I'll write this value here. So e raised to zeta omega n in bracket, the value of that time period is 2 pi divided by root 1 minus zeta square into omega n. This omega n will be cancelled with this omega n, and finally we'll left with e raised to 2 pi multiplied by this zeta inside, so 2 pi zeta divided by root 1 minus zeta square. So here it will be xa by xb. Now we will have to remove this e, so take the log on both sides. So this will become log to the base e xa by xb is equal to 2 pi zeta divided by root 1 minus zeta square, and this log to the base e for xa by xb is called as logarithmic decrement. So that logarithmic decrement is denoted by delta, and this becomes 2 pi zeta divided by root 1 minus zeta square, and this delta is nothing but logarithmic decrement. Okay, so this is the derivation. This is the simple derivation of logarithmic decrement. Just I'll revise. See, whatever I have written in this top corner, if we don't know, then it will be difficult for you for the derivation. This I have taken from the derivation of damped vibration. Displacement of damped vibration is given by this equation. So this total first term is nothing but amplitude into sine omega t, which is the equation of SHM. So this total first term is nothing but the amplitude, and in this graph I have shown the amplitude at A, amplitude at B, and the time between A and B is nothing but the time period. So time period is 2 pi by omega, and I have written here the value of omega d, that is the damped vibration. Okay, so this TB by TA we have taken from the graph. So from the graph, right here, from the graph TB minus TA. So first I have taken TB minus TA, means time period for B minus time period for A, which will require in further derivation. So I have taken the amplitude at A, amplitude at B, then we have taken the ratio of XA by XB, then we have cancelled the terms, we have transferred E into the numerator, then we have combined these two E, and finally we have put the value of TB minus TA, and we got the ratio of logarithmic ratio of xa by xb, and this is nothing but the logarithmic decrement. Thank you.